Hello, Mr. Betts here. We have a problem with differentiating inverse functions here that's a multiple choice problem, and it tells us that a and b are inverse functions of each other, and we want to know which one agrees with this equation here that the derivative of b at 5 is going to be 1/4, sorry. So essentially what that means is we're looking for a point on a where a of some number is equal to 5 and a prime at that number is equal to the reciprocal of 1/4, which is 4. Okay, so the point, if we think about corresponding points here on A and B, uh, the point in question is going to be 5 comma something, which I'm going to call C. So we're looking for the derivative of B at 5 is going to be 1/4. So the corresponding point over here is going to be C comma 5, and the derivative at that point is going to be the reciprocal, which is 4. So I'm going to take each option here and just treat it as like a true false question. So I'm going to do each one individually and say yes, it agrees with that, or no, it doesn't. So the first one here, we have to figure out what we would put in for a to get 5. So a of what is going to equal 5? It looks like we're going to be adding something to 4, so we should be adding 1. If we plug 0 in for a, we're going to have e to the 0 plus 0 cubed plus 4, which is going to be 1 plus 0 plus 4, which is 5. So the point in question then, we want to know what a prime of 0 is. If that's 4, then this is going to be our answer. So the derivative, a prime of x here, is going to be derivative of e to the x is e to the x. Derivative of x cubed is 3x squared. So a prime of 0 is going to be e to the 0 plus 0, which is 1. So this one does not work. Part B, we need to figure out what we plug in here to get 5. So just doing some mental trial and error, if we plug in 1 for x, we're going to get 5. So we want to know what is a prime of 1. So notice that the values that we're plugging in for a depend on what the function is, because the function has to have a value of 5 at that point. So a prime of x is going to be derivative of 3x plus 2 is just 3, which means that a prime of 1 is also going to be 3, and that one also doesn't work. So treating these as true, false, both of the first two are false. Next one, a of something is 5. This one's a little bit trickier here. 0 doesn't work. Usually a problem like this, they're going to give us something pretty easy. So let's try 1. If we put 1 in, we have 1 plus 5 plus 10 is going to be 16, minus 11 is 5. So that works. By the way, I do want to point out, it's not mentioned in this problem, but every one of these functions is a strictly increasing function, so they are invertible. We don't have to address that because it does say that the functions are inverse functions. So that takes into account that the functions are one-to-one, and they are therefore invertible. So we want to know again, what is a prime of 1? So a prime of x is going to be 3x squared plus 10x plus 10. So a prime of 1 will be 3 times 1 plus 10 times 1 plus 10, which is 23. So it looks like the slope of the inverse function there is going to be 1/23rd, so that doesn't work. Hopefully D does, because we are running out of choices. So figure out what we plug in for x here to get 5. This one's pretty easy, because if we plug 0 in for all the x's, we get 5 left over here. So we want to know what is a prime of 0. Hopefully that's going to be 4. So a prime of x is 5x squared plus, oh no, not 5x squared, 5x to the 4th, plus 4x cubed, plus 4 plus 0. So a prime of 0, anything with a 0 drops out and we get 4. Looks like that's a winner, because the derivative at 0 on a is 4, meaning the derivative at 5 on b is going to be the reciprocal of 4, which is 1/4. So D will be our answer here.